Okay, today we're going to be looking at the representation of continuous data. So for that we use a cumulative frequency graph. So what does that mean? A cumulative frequency graph is the total frequency of all the values less than a given value. Now that will make sense once we start to look at an actual example. If we then, so let's say we have grouped data. We would then construct can I spell construct as an R and R? Construct a cumulative frequency diagram by plotting the cumulative frequencies. Oops. And we use the abbreviation CF. I'm just going to use this abbreviation CF because it's a lot to write every time. And we plot the cumulative frequencies against the upper class boundaries. For all the intervals. We can join the points constructively with a straight line segments to give a cumulative frequently polygon. So say you've got you've plotted a graph and you've got your upper class boundaries down here. What am I writing? Boundaries. And then you've got your cumulative frequency up here, and say you've got some points here. Now, you can plot them. We'll use a different colour by doing straight lines between the different points. So these straight line segments they give a cumulative frequency polygon. Okay, so that's a straight line. Or, it's not going to be very clear on this. We choose a different colour altogether. You can draw a smooth curve. Okay, so that this is you can do a smooth curve. The difference between the smooth curve and the straight line isn't very clear on my little diagram. But if you do the smooth curve, what you've got here, that is called a cumulative frequency curve. It's maybe a good idea to have, if you're plotting them on the same axis, which we're going to do in a minute on our example, to have two different colours, just so that they show up properly. and then label it so one's, make it clear one's the polygon and one's the curve. Now what we can then use this for, let me get the black up, the cumulative frequency graph is really useful. It can be used to estimate or proportion, oops, an error for my writing, proportion values that lie between the points. So you can always, you could, like say if you wanted to know what this value is, you can then get an idea of the frequency. There's no given rule of which one's better, a polygon or a curve. If it's difficult to fit a smooth curve through the set of points, you'd maybe be better doing the polygon. And the other problem with the curve is that it's kind of a curve of best fit, so every different person is going to do a slightly different curve, which would therefore, if you're then trying to find out values, will make there'll be a degree of uncertainty. And so a polygon isn't going to have that same level of uncertainty there as the curve would have. Now we can use, so yeah, when we're using the curve, when we're doing the cumulative frequency polygon, we're making the same assumptions that we've made previously in the histograms when we're calculating estimates. That is that there's going to be a uniform spread of the results through different values and classes. Let's look at an example and it will become a bit clearer what all this means. So we're going to have a table which has the lengths of 80 leaves, on a tree, and they're given to the nearest centimetre. So we've got our lengths, centimetres, and we've got the number of leaves. So between 1 to 2 centimetres, we've got 8 leaves. From 3 to 4, we've got 20. From 5 to 7, we've got 38. From 8 to 9, we've got 10. From 10 to 11, we've got 4. Now, we want to draw a cumulative frequency curve and the cumulative frequency polygon, and then we're going to use these to estimate the number of leaves that are less than 3.7 centimetres long, and B, the lower boundary of lengths of the longest 22 leaves. So the first thing we need to do is create a table with the cumulative frequencies. So now if you're given this kind of data, because if you think about the leaves can take any value, that you know that this is not going, this wouldn't be a histogram, this would be the cumulative frequency curve. So the first thing to do is let's calculate the cumulative frequencies of these leaves. So we're going to look at the different lengths, and then we're going to have the addition of frequencies, and the number of leaves. So this is the CF, this is the cumulative frequency. So let's just notice something here. So a leaf, if the leaf is in less than 1 centimetre, so say there was a leaf, and a leaf could be like, you could have a new leaf and it could be less than 1 centimetre. 0.5. Now we don't have any of these, because if there was one that was below 0.5 centimetres, we would have another part in this table. So there's 0 here, and so there's 0 here. But what if we had a leaf that was half a centimetre? Well, that would be rounded up to 1 centimetre. So we're having leaves that are going to be less than 2.5, because anything that is below 2.5, so if we put 2.5 here, if a leaf was 2.5, it would be rounded up here. But if it's less than 2.5, even though it would say it was 2.49, it would be rounded to 2. So we've got the 0 from the previous one, add 8, because there's 8 leaves that are between 1 and 2 centimetres. So that's 8. Now, what about leaves that are less than 4.5? So all the leaves that are less than 4.5, well, that's going to be the 0 plus 8 plus 20. So that's going to be 28. Now, what about the leaves that are less than, now if you look here, 5, this includes 5, 6, 7. So this is leaves less than 7.5. So it's 0 plus 8 plus 20 plus 38, which is 66. And for leaves that are less than 9.5, we have 0 plus 8 plus 2 plus 38 plus 10, which is 76. And then for the leaves that are less than 11.5, we've got 0 plus 8 plus 2 plus 38 plus 10 plus 4, which is 80. So we're now going to draw, I'm going to have to get rid of the table in order to draw our graph, I'm afraid. So here's our graph, and we went up to 80 on it. So 0 here, 20, 40, 68. So we'll do 20, 40, 60, 80. So that's our cumulative frequency, and it's the number of leaves. And along the bottom axis, we will have 2, 4, 6, 8, 12. So we'll go 2, 4, 6, 8. Oh, we're not going to have enough room. Nice. we'll have 2, 4, 6, 8, 10, 12. So what did we have? At 0 we had 0, and at 2.5 we had 8 here. At 4.5, less than 4.5, we had 28 here. At less than 7, oh, it's going to be, oh, it's in, oops, oh no, why is that doing that? Let's just, okay, I forgot I counted up in 2s, so we'll go back, that's right. So 2.5, so that's 3, that's going to be 2.5 here, that was 8, so there's 8, 4.5, there's 5, so 4.5 will be about here, that's going to be 28, 7.5, that's 66, 9.5, 76, and 11.5, 80. So we want to plot the polygon. Now I'm going to change colours. So the polygon is when we do a straight line through each of these. Now use a ruler to do that, because that's not a very good straight line. Now we wanted to estimate the number of leaves that is less than 3.7. So for the polygon, for leaves less than 3.7 centimetres, we find 3.7 be here, and we kind of go up, and then we go over to here, that's not very accurate, that'd be 3.7, so here, and that would be 20 leaves. We want to find the lower boundary of the last 22 leaves. So we would do the opposite. So we had there's 80 leaves in all, and if we minus 60, or minus 22, that's going to give us 58. So we found 58 here. And then we come down now. When you do it yourself, you'll have a better you'll have rulers, and you'll be able to have a better work out the best scale. So for the polygon, the lower boundary for the 22 longest leaves is going to be about 6.9 centimeters. Now, we're going to do a curve of through this now. Let's choose a better colour. We'll do green. So what we would do is, had this lower axis been better spread out, you would be getting something that looked like that. So we'll try and recreate that. It's a bit rubbish. So you see how your curve can be, it's not, there's a bit of variability, there's more variability in the curve than in the polygon. So we wanted leaves for the curve, leaves less than 3.7. So again, we find our 3.7 here, that comes up to here, and this gives us a different value. We'd say it's about 18 leaves. And for the lower bound, I was going to put LB, longest 22 leaves. If we have, here's our 60 again, and if we come down, it's again, it's not quite, kind of comes down to about here, and it's kind of at the 6.7. It's less, it looks less than 6.9 anyway. So yeah, the key to these is you are careful with your drawing of the curves, and that awareness that the curve and the polygon are going to give you slightly different results. So I hope that helps.